The most mysterious objects in the universe, black holes and supernovas. Have you ever imagined a place where gravity is so powerful that not even light can escape? Or an explosion so energetic that, for a few weeks, it can outshine an entire galaxy? It might sound like science fiction, but these are real events happening somewhere in the universe right now. Today we're going to explore two of the most fascinating phenomena ever discovered, supernovas and black holes. We'll see how they are connected, how scientists discovered them, and we'll uncover some incredible facts that completely change the way we think about space. Let's start with supernovas. Every star in the universe is essentially a gigantic nuclear reactor. Deep inside its core, enormous amounts of pressure and temperature allow hydrogen atoms to fuse together and form helium. This process releases incredible amounts of energy, creating an outward force that balances the inward pull of gravity. For millions or even billions of years, a star remains stable because these two forces are perfectly balanced. However, no star lives forever. Eventually, it runs out of the fuel that keeps its nuclear reactions going. For stars that are much more massive than our Sun, usually at least 8 times its mass, the ending is spectacular. Once the fuel is exhausted, gravity suddenly takes over. The core collapses in less than a second, reaching unimaginable densities and temperatures before rebounding in one of the most violent explosions in the universe, a supernova. A single supernova can briefly shine brighter than an entire galaxy containing hundreds of billions of stars. In just a few seconds, it releases more energy than our Sun will produce during its entire lifetime of around 10 billion years. But supernovas are much more than beautiful explosions. They are responsible for creating many of the elements that make life possible. Gold, silver, iron, uranium, and even the calcium in your bones were forged inside massive stars and scattered across the universe when those stars exploded. This inspired the famous astronomer Carl Sagan to say, "We are made of star stuff." It sounds poetic, but it's also scientifically true. Almost every atom in your body was once inside a star that lived and died billions of years before our solar system even formed. So what happens after such an enormous explosion? The answer depends on how massive the original star was. If the remaining core is relatively small, it becomes what's called a neutron star. These objects are incredibly dense. To give you an idea, just 1 teaspoon of neutron star material would weigh about 1 billion tons on Earth. That's roughly the same as a mountain compressed into a teaspoon. However, if the remaining core is even more massive, gravity becomes unstoppable. The core continues collapsing until it forms one of the strangest objects in existence, a black hole. Despite the name, a black hole isn't actually a hole. It's a region of space where gravity has become so intense that nothing can escape, not even light. Around every black hole is an invisible boundary known as the event horizon. Once anything crosses this boundary, escape becomes impossible. Because light itself cannot leave, black holes are completely invisible. We don't observe them directly. Instead, astronomers detect their presence by studying how nearby stars move or by observing hot gas spiraling around them before it disappears beyond the event horizon. The idea of black holes has an interesting scientific history. In 1915, Albert Einstein introduced his theory of general relativity, completely changing our understanding of gravity. Instead of thinking of gravity as a simple force pulling objects together, Einstein showed that massive objects actually bend space and time itself. His equations predicted that under certain extreme conditions, matter could collapse into incredibly dense objects where gravity becomes almost infinite. Interestingly, Einstein himself didn't believe that black holes really existed in nature. He thought they were only mathematical possibilities. A few decades later, the brilliant Indian astrophysicist Subrahmanyan Chandrasekhar studied what happens when massive stars die. While traveling by ship to England in 1930, he began calculating the maximum mass a dying star could support before gravity overwhelmed it. His work suggested that sufficiently massive stars must inevitably collapse. Many scientists at the time rejected his conclusions, including the famous astronomer Arthur Eddington, who publicly criticized his ideas. Years later, observations proved Chandrasekhar was correct. His calculations became one of the foundations of modern astrophysics, and in 1983 he received the Nobel Prize in Physics. Today, black holes are no longer theoretical objects. Scientists have found compelling evidence that they exist throughout the universe, from relatively small stellar black holes to gigantic supermassive black holes located at the centers of galaxies. Now let's explore some fascinating facts that make black holes even more mysterious. One of the strangest predictions of Einstein's theory is that time itself slows down near extremely strong gravitational fields. Imagine you could safely orbit very close to a black hole while your friend stayed on Earth. For you, only a few hours might pass, but when you returned, your friend could have aged several years. This phenomenon is known as gravitational time dilation, and although the effect is usually tiny around planets and stars, it becomes enormous near black holes. It's one of the most surprising consequences of modern physics and has even been confirmed through extremely precise experiments involving satellites and atomic clocks. Another amazing milestone happened in 2019, when scientists released the first-ever image of a black hole. This achievement was made possible by the Event Horizon Telescope, which isn't a single telescope but a global network of radio telescopes working together as if they formed one giant Earth-sized instrument. The black hole photographed lies at the center of the galaxy Messier 87, about 55 million light-years away. Since black holes themselves cannot be seen, the image actually shows the glowing ring of extremely hot gas surrounding the event horizon. The discoveries didn't stop there. In 2020, the Nobel Prize in Physics was awarded to Roger Penrose, Andrea Ghez, and Reinhard Genzel. Roger Penrose demonstrated mathematically that black holes naturally arise from Einstein's equations, while Andrea Ghez and Reinhard Genzel spent decades tracking the motion of stars near the center of our Milky Way. Their observations provided convincing evidence that our galaxy contains a supermassive black hole known as Sagittarius A*, which has a mass about 4 million times greater than our Sun. Here's another misconception that movies often get wrong. Many people imagine black holes as giant cosmic vacuum cleaners that swallow everything around them. In reality, that's not how gravity works. If our Sun were magically replaced by a black hole with exactly the same mass, Earth would continue orbiting almost exactly as it does today. The only major difference is that without sunlight, our planet would quickly become frozen and lifeless. The black hole wouldn't suddenly pull Earth into it because gravity depends on mass, not on whether that mass is a star or a black hole. Scientists have also discovered black holes so enormous that they contain billions of times the mass of our Sun. These supermassive black holes sit at the centers of most galaxies, including our own. Despite their incredible size, researchers are still trying to understand exactly how they formed so early in the history of the universe. Even today, black holes remain one of the greatest mysteries in science. Physicists still don't know what happens inside the event horizon or whether information is truly lost when something falls into a black hole. Solving these questions may require an entirely new theory that combines Einstein's general relativity with quantum mechanics, two of the most successful yet incompatible theories in modern physics. Supernovas and black holes remind us that the universe is both violent and beautiful. The same explosions that destroy stars also create the elements needed for planets, oceans, and life itself. Meanwhile, black holes challenge our understanding of space, time, and the very nature of reality. Right now, somewhere in the universe, a massive star is probably exploding as a supernova, while another is collapsing into a black hole. The light from these events may take millions or even billions of years to reach Earth, meaning that the night sky is constantly changing even if we cannot yet see it. The universe is far stranger than we ever imagined, and with every new discovery, scientists uncover even more questions waiting to be answered. Perhaps that's what makes astronomy so fascinating. The more we learn, the more we realize how much there is still left to discover. If you enjoyed this video, don't forget to leave a like, subscribe to the channel, and let me know in the comments, if you could safely witness one event in the universe, would you choose to watch a supernova explode, or would you rather observe a black hole up close? Thank you for watching, and I'll see you in the next video.